Yo, what is up YouTube? In this video, we're going to take a look at Thevenin equivalent circuits. So Thevenin equivalent circuits has a voltage source, VThev, and then a resistor, RThev, in series with it, and then two terminals, A and B. So we're trying to represent this big circuit as this over here. Pretty cool stuff. So the first thing we want to do is find VThev, which is equivalent to the open circuit voltage. And in this case, this diagram nicely labels it VAB. So for us to solve VAB, what we're going to do is find the voltage across this 60K ohm resistor. And if we know that voltage and we sum the voltages around this loop, we get that this voltage V1 is equal to VAB because there's no current going through this, I equals 0. And if we did negative V1 plus VAB equals 0, we find that V1 is equal to VB. So let's go ahead and find V1. So finding V1, this is a node right here. We'll call it V1. And we have our ground node already drawn for us. And we want to find V1 with currents, Kirchhoff's current law. So let's label this current going in, this current going out. And what we have is, this is negative 36 volts. And it goes to V1 and it goes over this resistor 12K. So we get negative 36 minus V1 over 12K. And then we have some current going into the node, and that's just a straight 18 milliamps. So plus 18 times 10 to the negative 3. And we have some current going out. So we have minus, and it's going from V1 to 0. So V1 minus 0 is V1. V1 over 60K, and this is equal to 0. And if we break up this fraction and have it be V1, negative V1 minus 36, both of those over 12K, we can move all the V1 terms to the right, factor out of V1, and solve for V1. So what this looks like is 18 times 10 to the negative third minus 36 over 12K is equal to V1 times 1 over 12K plus 1 over 60K. Go ahead and review that algebra if that didn't make sense right away. But if we go ahead and divide both sides by 1 over 12K plus 1 over 60K, we get that V1 is equal to 150 volts. So right there, we could add it. 150 volts. VThev is 150. Awesome. The next step for us to do is find the resistance. And in the case that we have only independent sources, we can turn voltage sources into short circuits and current sources into open circuits. This updates our circuit to look like this. We have a 12K here, a 60K here, 15K here, and then our terminals A and B. So we want to look, what's the resistance seen at here? This is going to be our RThev. So we have, here I'll point it out, we have 12K, and 12K is in parallel with 60K, and those two together are in series with 5K. So we have 12K parallel with 60K, plus 15K equals RThev. So this is 12 times 60 over 12 plus 60 plus 15K, and this works out to be 25K. So our RThev there is 25K, and we've completed our Thevenin equivalent circuit. Awesome.